All right, so we are off and running into chapter one, and I thought chapter one did a pretty decent job at defining and discussing at first all of the elements of what you might call a statistical analysis. If there, and it did that in section 1.1. To me, if there was any shortcoming, you had to read very carefully. There was just one short paragraph that gave you some inkling of how these various terms and activities and entities are related. And that's what I wanted to quickly do here. I wanted to call this the statistical circle of life. Be careful using that. I made that term up. It's not general usage by any means. So I want to discuss these statistical entities and activities. And let me make a little color scheme up right here. I'm going to use this when I'm talking about entities, and I'm going to try to use this when I talk about activities. If your monitor doesn't distinguish those two colors, not to worry, you won't have any trouble following this. So an analysis all starts with an interest in learning something about or making an inference about a population. So a population brings to mind groups of people, but it's a much more general term than that. It really has no limitations as to what it could be. It could indeed be groups of people. It could be all the people in the United States. It could be the males in the United States. But it doesn't have to be people. It can be something as finite as the 6 sides of a 6-sided die. 1, 2, 3, 4, 5, 6. It could be the 52 cards in a deck of standard playing cards. There is no limit to what the population can or cannot be, but it's on you to draw a circle around it and say, this is my population. And you're going to want to distinguish that population, and I'll show you why in just a second, because often it's the case that the population is intractable, impractical, often too large to allow you to go and query every element of that population to learn what you want to learn. If you wanted to determine the average height of males in the United States, you don't want the job to take your clipboard and go door to door and write down all the heights. There's 150 million males in the United States. So in that situation, what we generally do is carve out a subset called a sample of that population, another entity. And the manner by which we carve that out is called sampling. And there's some discussion of sampling in chapter 1. I will tell you that I'm not going to let you spend too much time on it. It's enough for you to understand the difference between random sampling and simple random sampling, but even that is not going to hold you up very much. Sampling is important because we want to learn something about the population. I'll continue to say that. We're going to do that by learning something about the sample. So we're only going to learn something about the population if that sample is somehow representative of the population. If you're going door to door trying to learn about the males, the average height of males in the United States, God forbid, don't start finding the heights of females because it's just not relevant. How you handle that sampling will determine whether or not that sample is representative of the population. Once you have the sample, you collect data. In this case, again, if we're looking to understand something about average heights, you're going to take each one of the elements of your sample and measure its height. And then you're going to compute a statistic. In this case, in the example we're using, the statistic would be the average height of every member of your sample. So this is nothing more than a property of the sample. There are many different statistics. In turn, we're going to start looking at every one of them. But I think you're already familiar with the average or the mean, and that's why I've used it here. So, we're given a population, we're interested in a property of that population. We are going to learn about it by taking a subset of that population, collecting data, and calculating a statistic. And then we hope that that statistic is an estimate of the parameter, the associated parameter of the population. The parameter is a property of the population. So if we're taking an SAT test, a parameter is to a population as a statistic is to a sample. And again, what we're interested in is convincing ourselves, validating that the statistic, I'm going to say accurately estimates the parameter. We're going to do that by checking on any number of things. Whether or not it's accurate depends on the statistic, it depends on properties of the sample, the size of the sample, for instance, and other features. So that's an activity that we have to follow. But at this point, we've gone from population to sample to statistic to an estimate for the parameter. We're almost done. And in fact, in a lot of cases, we are done. But in other cases, we might want to draw an inference about that parameter. We might want to say, for instance, we might want to test whether or not the average height of all males in the United States is greater than 6 feet. And we would make an inference to that effect, and we would validate that inference through any number of methods and tests. Validate any inference, I'll just say that. And that's what we're doing in this class. We're identifying populations, we're given problems in which we're interested in trying to make sense out of a property of the population. We'll sample it and pick a sample, we'll collect the data, calculate statistics, we'll convince ourselves that those statistics accurately point to the associated parameters, and at the end of the day, we'll test any inferences that are made. If I draw a line like this upper half or quadrant is kind of the realm of descriptive statistics. We're taking suitable samples, we're collecting data, we're organizing that data, we're presenting that data. Down on the lower side here is kind of a purview of inferential statistics. Inferential statistics and the scientific method are in lockstep. Yeah, it's inferential statistics that kind of drives the scientific method and gets you from a hypothesis to some sort of proof of that hypothesis. All right, so there it is. Statistical circle of life. Excellent.